students, welcome back. Again, you're going to need a paper and a ruler, and I'm using a marker because it's darker. That'll work a little better. But today we're going to do some more geometry. So the first thing you're going to do is you're going to use your ruler to draw an angle on your paper. So any angle you want. I just drew a big angle there. And what I want you to do is pause the video and try to find a way to split that angle in half. How can you find the angle bisector? So pause the video, take a few minutes to find out how to do that, and when you're ready, restart it. So the way I did it is I folded it. Let's see if you can see this a little better. And I folded it right across so this side matched up with that angle. And that line we're going to draw is the angle bisector. Now it's not going to be exact. It's a little hard to do. But that line where it folded is the angle bisector. So part two is you're going to draw a triangle. And I think if you make a triangle bigger, it's a little easier. So you're going to make a big triangle on your paper somewhere. And what you're going to do with that triangle is you're going to find the angle bisector of each angle in the triangle. So you're going to do the angle bisector here, here, and here. All right, so pause the video, take maybe 5 to 10 minutes to do that. And then when you're ready, restart that video and we'll do some exploring with that. So, if you did it right, you should have about gotten that all three of these points, or all three of these angle bisectors meet at that central point right there. So we're going to do some exploring with that in just a second. So this is a tool called GeoGebra Geometry, and if you Google that, you'll find this exact tool. But I just created a triangle in it, and I'm going to use this tool, which is the angle bisector. So if I pick two sides, it actually does the bisector for me. So I'm going to do that for all three angles of this triangle I created. And what you can see is they meet up at this point in the middle. Okay. So the other thing, if you'd like to do this with your triangle, you can. If not, that's okay. But we're going to draw a perpendicular line from a side to our center. So you can do that by folding it across until it goes through that center point, if you'd like to do that with us. The GeoGebra tool will actually do it for us. So there's this tool that's perpendicular line. So I'm going to choose that line going through that center point D. So this actually drew that line for me. So this line right here, this makes 90 degrees. And we're going to make a circle because this point is called the incenter. It's in the center of the circle, so the actual center of the circle. So we're going to go here and we're going to do circle with center. So I'm going to click circle here, right in the middle, and I'm going to draw it to that edge right there. And what you can see is the circle fits perfectly and touches all three sides of that triangle. That is the incenter. So the next thing I want you to do with the incenter is you're going to cut your triangle out. So I'm going to cut my triangle out, and I didn't actually draw the circle on this triangle, but I still have that incenter point. So I'm going to cut this out. And what I want you to do is you're going to take your pencil, and you can actually see, and if you put your pencil right at that incenter, if you did it right, that's the balancing, let's see, that's the balancing point of your triangle. It'll balance perfectly there. So that's what the incenter does. Oh. So I want you to take a second and add this to your toolkit. So what it's saying is that the incenter of a triangle, this middle point right here, is that all three of these, since we made a circle, all three of these lines are equal right there. That's the big idea behind this incenter theorem. So a way we would use that is in a problem like this. So it says ND equals 6x minus 2, NE equals 3x plus 7. So find NF. So we have ND is 6x minus 2, and E is 3x plus 7. It says find NF. So what we're going to do is, since we know these are the same from the incenter theorem, we can say 6x minus 2 equals 3x plus 7. So we're going to subtract 3x to both sides, add 2, 3x equals 9, x equals 3. So that's just x. We still need to find that length. So let's find the length of NE. We're going to have 3 times 3 plus 7. 9 plus 7 gives us 16. So if this is 16, if NE is 16, that means NF also has to be 16. So that's how we're using the in-center theorem. So for part 2 of our lesson, you're going to get a new piece of paper and you're going to draw a triangle. Remember, if you make it bigger, it makes it a little easier. I'm using a marker just so it's a little darker for when we're folding. You're going to draw a triangle nice and big in your paper. You're going to use that triangle. And what you're going to do is you're going to find the midpoint of each side. So to do that, we're just going to fold it over itself and match those 2 points up. You're going to find the midpoint of each side. So pause the video, take just a little bit to do that, and then resume when you're ready. So through our folding, we found the midpoint of each side, and what you're going to do is you're going to connect the vertex to the midpoint on the opposite side. So for all 3, you're going to connect those. So again, pause, make that connection, and try to see what you notice. So this point where they all meet is called the centroid. And, excuse me just a sec. So this point where they all meet is called the centroid. And what I want you to do is you're going to measure this length here and also the length below it. And you're going to do that for all 3 parts and see if you can notice a pattern. So do that for all 3 of those lines. And you're going to measure those lengths and try to look for a pattern. So once you measured all those sides, you're going to divide them out. And what you'll notice is that all of these, 6.5 divided by 3.3, 8.8 divided by 4.4, and 10 point, and that's a 2, divided by 5.0, all of them come out to about 2. That's the property of the centroid. So here's the centroid theorem, and I want you to add this to your toolkit, obviously. And what it says is that if you look at this BF, this whole side, that this is 2/3 the whole length, and this is the other thirds. Also saying if this was X, this would be double whatever that bottom side is. So pause this video, add this to your toolkit, and then we'll show how it applies. All right, so coming back, how we can use that is a problem like this. We know QN is 21, and if this is our centroid here, what we know is we want to find what is this length and what is that length. So we know this length is 2/3 times 21, and I just do 21 divided by 3 is 2 times 7, which gets us 14. And if that's 14, that makes this 7. Pretty simple example of how we can use this. Another way to use it is here, and this is with a little more algebra. So what we have here is this is saying that BD is 4x plus 5, and BF, the entire length, this whole length, is 9x. So we know the whole length, that 4x plus 5 is 2/3 of that whole length. So what we're going to have here is we know that 4x plus 5 equals 2/3 of 9x. Of in math means multiplying. So 2/3 of 9x gives us 6x. And so we're going to subtract 4x to both sides. And we get 5 equals 2x. Divide them both by 2. And you get 2.5 equals x. That's how we solve for x in that diagram. All right, thanks for joining us. There is Clever homework on Clever regarding these last two parts. It's 6.3 and 6.4. So log on to Clever and get some of those practice problems done using these two new properties. Thanks for joining us today.